Howdy. We'll do a quick review of simultaneous equations, which in the United States we call systems of equations. One of the things to keep in mind is what a solution to a single equation is, and what that is, it's a value. In this case, if you have an x and y, it's a pair of values that make this equation true. So I've got y equals x plus 2 graphed here. I've got a y-intercept of 2, slope of 1. Every single point on this graph, on this line right here, is a solution. So for example, 1 comma 3, x is 1, y is 3. I get a true statement because 3 equals 1 plus 2. So when you have a system of equations, like this system right here, y equals negative x and y equals x plus 2, what you're looking for is the point they share, the solution they share. So a solution to this system is a solution to both equations. So I went ahead and graphed in red y equals negative x, and where they cross is negative 1 comma 1. That's the solution to this system of equations, and that's how you can find it by graphing. The thing is, with graphing, if they don't cross at a lattice point, which is like a corner on a regular piece of graph paper, then you sometimes need to use another method to come up with an exact answer. Thing is, with these systems of equations, when you're asked to find the solution, you're being asked to find this. It doesn't really matter, unless the instructions are explicit, it doesn't really matter what method you use. So there are 3 methods. The first is graphing, which is this, and the other 2 are substitution and elimination. So with substitution, you're doing just that. You're substituting one value that's known for another. So in our first example A here, 3x plus y is 2, and y equals x minus 2. I happen to know what y equals. Y equals x minus 2. So I can just substitute that into this equation. So I'd end up with 3x plus x minus 2 equals 2. Do some solving here. So 3x plus x is 4x. Add 2 to both sides. Negative 2 plus 2 is 0, and that would be 4, so x is 1. Since x is 1, I can just plug that in right here, and I see that y equals negative 1. Now, on a Cambridge exam, your answers are separated like this, but often in the United States, you're asked to write your answers as an ordered pair. But it doesn't matter, the information is the same. Another time that substitution lends itself nicely to solving a system is when it looks like this. Since this is a set of simultaneous equations, y is the same as itself, so that means that this equals this. So x plus 4 equals 2x minus 1. All you got to do now is solve that. It's easiest to move the x with the smaller coefficients, so 4 equals x minus 1. So 5 is what this is going to be, because 5 minus 1 is 4. So x is 5. Now you just plug that into either equation, and you see that y is 9. Now, on to elimination. When the equations are written in these fashions here, elimination often is the easiest way to solve them. What you're going to do is literally just add the like terms in a column. So you see I have 2x, so I have like ax plus by equals c, and ax plus by equals c. So I can just add these together. Look, I get 5x. Y minus y is 0. So x is 1. And then you can take that number for x and just plug it into either equation. So 2 times 1 plus y equals 0. So y has to be negative 2 because 2 minus 2 is 0. This is perhaps the trickiest kind right here. It's really not so bad. See, look, if you add them up as they were right now, you would get 7x plus 7y is 28, and you didn't eliminate anything. The method's called elimination because what you're going to work at is eliminating one of the letters. So one thing you can think about is lowest common multiples. Like, you're going to multiply both equations by a number to eliminate one of the variables. So if I were to want to get rid of the x's, I could multiply this by a negative 3 and this one by a positive 4, and they would become positive and negative 12x. Or what I'm going to do this time, I'm going to multiply these equations to get rid of the y. So I'm going to multiply this by a negative 5 and this by a positive 2. Thing is, you have to make sure you distribute to absolutely every single term. So what I'm going to get is negative 20x minus 10y equals negative 50. Then I'm going to get over here, I'm going to get 6x plus 10y is 36. Now I can take those two equations and just add them together, like this right here. So negative 14x, 0y, perfect, is negative 14. So x, it looks like x is equal to 1. Now with this, I'm going to take this and I'm going to plug it into one of the two equations. It doesn't matter. I'm going to plug it into the second one. Now I'm going to solve that for y. So I'm going to subtract 3 from both sides. So y is 1. So those are my answers, 1 and 1. Now last thing, checking your answers. This right here is only a solution to the system if both equations are true. So when I have both equations and they work, so what I'm doing here is I'm taking this equation, I'm going to plug in my solution for x and my solution for y. If that equals 10, and if this one works, that equals 18. If they both work, then I found the solution. If neither works, I'm wrong. So here I have made a very silly mistake. See, this is not the answer because that's 6. That doesn't equal 10. Even if this one was true, there's a problem. So, especially with the more difficult ones, you want to check your answer. If you're taking a big paper 4, maybe put an asterisk beside the problem when you got your solution, and then at the end of the test, if there's time, go back and check. I can look right here. Here's my mistake. Like, if I had written out my work, I probably would have seen that y equals 3. And if I change this to a 3 over here, 4 plus 6 is 10. That's true. That works. If I change this to a 3, 3 plus 15 is 18. So my answer is this, not that. So anyway, I hope this video helps you understand how systems of equations work, and good luck.